Hi, today we're going to talk about vulnerability to exploit to patch time. So the relationship of the discovery of a vulnerability, and we'll talk about this ecosystem that develops vulnerabilities in a later lecture. So discovery of vulnerability to development of an exploit among the adversary. So that's whether it's Russian or Chinese or cyber criminals or whatever. Okay, so announcement of vulnerability, development of an exploit to the vendor makes a patch available. So we're going to look at that time relationship. Okay, so you see a graph. It hardly matters what year or what period, but that represents two 6-month periods. And you see for various vendors how long it takes them to develop a patch, right? That's from discovery of a vulnerability to development of a patch. We're going to talk about exploit in a second, okay? So announcement of vulnerability, discovery of a vulnerability to the development patch. And you see some vendors are better than others. But that we'll talk about the average in a second. So then this is the time to develop an exploit. So you see for a similar period, it doesn't exactly overlap, but it's just the relationship that's important here, not the time period, okay? Because the time period you're going to see is pretty much about the same. So we're just looking at the relationship. So this is the average over 3 6-month periods to develop an exploit. All right. So if you look at it takes the vendor about 54 days. It takes an average vendor about 54 days to develop a patch. And it takes the cyber criminals, the adversary, about 6 days to do an exploit. So if you're a cybersecurity manager, if your responsibility is to protect the organization against a cybersecurity threat, there's the problem right there. You get a vulnerability, it's going to take the vendor 54 days to fix it. It only takes a cyber criminal about 6 days to develop an exploit. So you can see the relationship there, right? Do you understand that? It takes much longer to develop a patch than it does an exploit. You can develop an exploit fairly quickly. All right, let's look at what Carnegie Mellon found. Carnegie Mellon did some research. They put HoneyNet boxes out on the internet. So that's the HoneyNet project. That was the responsibility of the HoneyNet project. They put some boxes out on the internet with software vulnerabilities in them. They installed web servers and they didn't patch the operating system. And there was a number of vulnerabilities, maybe 100 vulnerabilities on each box. And they just stuck them out on the internet. Okay, and the question they wanted to answer was, did the attack frequency increase if the vulnerability was disclosed? Okay, that's the question they wanted to answer. Did the attack rate increase if the vulnerability was disclosed? All right, so Carnegie Mellon did this. This was a couple of years ago. I put on Blackboard the underlying research paper that was written that led to these slides. Okay, so if you're interested in that, you can read the entire paper and see the development. I just picked out the highlights, okay? So here's the rate of attack. You notice it goes from about a year before the patch comes out to about a year after the patch comes out. And you can see the attack rate is relatively high when the vulnerability is first discovered. That makes sense. And then once the patch comes out, remember, this is over a year, and we learned that the vulnerability discovery to vendor patch time was average about 50 days. Okay, this is a year. That's because they put 100 vulnerabilities on the box. Okay, that's why the difference. So you can see the attack rate is relatively high when the vulnerability is discovered. It goes down. Once there's a patch, the attack rate goes down because system admins will patch their boxes. But look, as time goes by, the attack rate goes back up again. So why do you think the attack rate goes back up? All right, so I'm going to leave you with that as a question for you to answer. And you can get extra credit if you answer it in email or in the discussion boards. Why does the attack rate go back up after time? Okay? That's part of critical thinking, to be able to say, oh, the attack rate goes back up over time, and I'm not going to tell you why. All right, research conclusions. Secret vulnerabilities get exploited less than patched vulnerabilities. Okay, and I think that sort of makes sense, but I'll explain that. Secret vulnerabilities are vulnerabilities that, say, NSA only has, and so they don't get exploited as often because no one knows about them, right? Not even the cyber criminals know about them. But once there's a patch, the attack rate goes down initially, but then goes back up again, right? So patch vulnerabilities get exploited more often. That's the other side of the same relationship there. Okay, published vulnerabilities. And by published vulnerabilities, I mean there's a process called responsible disclosure. So you, as a security researcher, if you find a vulnerability, then you're supposed to give the vendor 30 days or something before you go public. That's called responsible disclosure. There's some argument about that. You know, should we be informing the hackers about vulnerabilities at the same time we tell the vendors? So we give the vendors 30 days to fix stuff. So that's called responsible disclosure. So published vulnerabilities without patches get exploited more often. So vendors should release patches, right? We're going through a cycle right now of Internet of Things, IoT cameras, right? A lot of them have to hook to the internet. They've got to pass data to the Ring data center or whatever. And the software that gets burned in firmware to connect to the internet, to upload data, to protect them, is written by some Chinese companies. And remember, we talked last time about any human endeavor, there are going to be bugs in it, right? And there's lack of rigor in testing and assurance. So the software you get that's inside of a Ring camera, not to pick on Ring or Nest or whatever, inside those cameras, in IoT devices, baby cameras, that sort of thing, hasn't been tested. You hook it up to the internet, to your home, and you plug it in, and there's bugs in that software. All right. So patching that is important. You should only buy a camera from a known manufacturer with a patching mechanism, right? Like Ring cameras or Nest cameras or some such thing that has a known update process. All right. Attackers take longer to develop when there's no patch, right? So their research said the sample average time from the first attack to the first attack is 40 days if there's no patch. Remember, we said 54 days when we analyzed 2 6-month periods. Okay, Carnegie Mellon is saying about 40 days from a discovered vulnerability to the first attack. It's about 2 months, okay? It's just think of it as 2 months. One source says 54 days, another source says 40 days. Just think of it as 2 months. So if you get a vulnerability without a patch, it's going to take 2 months for you to get a patch. All right? As opposed to when vulnerabilities are published with a patch, the sample average time to the first attack is 16 days. So the other source said 6 days. This says 16 days. Just think 1 week, okay? In 1 week, the bad guys will have an exploit. It's going to take the vendors 2 months to fix it. That should scare everybody, okay? So suggesting that patches provide information to the exploiters, why is that? How does the patch provide new information to the guys that provide an exploit, who develop an exploit? And it's mostly guys, okay? That's, who are cyber criminals and do this sort of thing. Notwithstanding the attack against Capital One, which was a woman, but there's some question about perhaps that was a transvestite and it really was a man. And so about 99.99% of the time it's a man responsible for cybercrime. Okay, so we're going to talk about in a future lesson why patches provide new information, how patches provide new information to attackers. Okay, if you think you know the answer, send me an email, put it in the discussion board, show me how much you actually know. But we'll spend a lesson talking about how patches provide new information. I'll give you a hint. It's called reverse engineering, okay? And finally, Carnegie Mellon determined that patching was generally a good thing, okay? So doing a patch is generally a good thing. All right, so we kind of went through that very fast. You might want to look at that a couple of times. You might want to do some research. You might want to read about it. But that's basically the vulnerability to exploit to patch timing. Okay, thanks. See ya.